Hello and welcome to today's GFG problem of the day. Hope you're doing well. Let's see today's problem. Remove half node. So what the problem is saying is we'll be given a binary tree, okay, and we want to remove all the half nodes. So what is a half node? A half node is a node which has only one child. So in this case, 7 is a half node because it has only one child, that is 2. Okay, so it can either be right. A half node is a node which has either a left child or a right child. Okay, so in this case, if there is a half node, we want to remove this node. Okay, we want to remove this node. So here, what the resultant tree will look like: 5, 2, and 8. So in this case, what we are doing is we are directly bypassing. We will directly bypass the 7 node, and we will make 2 as a left child of 5. Okay, so in this case, so this will be the resultant tree. So what we want to do is we want to return the root node. Okay, finally. Okay, now how can we solve this problem? So what we are going to do is we will do the post order traversal of this tree. Okay, post order traversal of this tree. What is a post order traversal? We process the left child of the node, then we process the right child of the node, and then the node itself or root itself, whatever it is. Okay, so here, for example, what we'll do is, for example, what we'll do here, we'll process with the 5, right? We'll go as per this order, right? We'll go to the left child. Again, here we'll go to the left child as per this, right? So we'll keep going to the left. Okay, now here also we'll go to the left, but here it is null, so we'll return, right? We'll return. Now, as per this order, we have done processing the left child. Now we'll process the right child. Again, here if we go left, sorry, if we go right, there's null over there, we'll return again. Okay, now we are done processing with right, we are done processing the left child and right child, so there's nothing. We'll go back, right, to 7, right? So 7, we are done processing the left child. Now we'll process the right child, so we'll go to the right, but it does not have the right child. We'll come back, right? We'll come back. Now we are done processing the left child and right child of 7. Now we'll process this node or root, that is a 7 itself, right? Now here, when we, for any given node, when we are done processing the left child and the right child, then we are going to check whether it's a half node or not. So how are we going to check? If root dot left is not null, and root dot right, if it is equal to null, right, then in this case, or the second condition can be, what the other condition can be: if root dot left equal to null, and root dot right is not null, right? That means if for any particular root or node, if any of this condition matches, that means it's a half node, right? It's a half node. So in this case, the left child is there, but the right child is not there. In this case, the left child is not there, but the right child is there. So in this case, right? In this case, what we are going to return? We are going to return root dot left. Root dot left we are going to return. So what we are saying is, so this is a half node, so we'll return root dot left to the parent node, to the parent node's left child. Okay, so this 2 will now point to the parent node's left child. Okay, and in this case, what are we going to return? We are going to return root dot right, right? In this case, we are going to return root dot right. Okay, so what we are doing is we are bypassing this particular node, and we at this step, right? At this step, we are saying return root dot left. Okay, so it will become the left child of 5. Okay, and hence we are bypassing this particular half node. Okay, so this is the intuition behind solving the problem. I hope you have got the intuition. It will be, I think you'll understand better with the code. Okay, before going to the code, also I'll request you to subscribe to my channel, as a lot of effort goes in making these videos. Okay, so let's quickly see the C++, sorry, the Java code. Okay, I had already implemented. Okay, let me re-implement again. Okay, so what we're going to do, first of all, the base condition. What will be the base condition if it is root is null, right? Simply return null. Then what we are saying is root dot left equal to first, what we'll do, we'll process the left child, right? According to the post order traversal, we'll process the left child, root dot left, right? And then what we'll do, we'll process the right child, root dot right. And then what we are going to do, now we'll process the node. Once we are done processing the left and right child, so here we are going to check if root dot left is not equal to null, and then root dot right if equal to null, right? In this case, simply return root dot left, root dot left, right? Else if root dot left, if it is equal to null, and root dot right? Then in this case, what we're going to return? Root dot right? So what we're saying here is we are returning root dot left, right? Root dot left. And also if you see here, right? So once this function returns root dot left, so it will go to the root dot left of that of the parent node. So this is a parent node. So whatever we return, root dot left or root dot right, so it is going to go to the left side of the parent node. Okay, that's what we are saying here. Similarly, here also it will go to the right side of the parent node if we are returning from here any root dot right or root dot left. Okay, so this is the code. Okay, so here we'll also return the root if everything is good, right? If it has two childs, or if it has no child, if it's a leaf node, or if it has two childs, so we'll simply return the whatever is a node, right? Whatever is a node. Okay, so this is the code. Okay, let's quickly compile this. Yes, let's submit it. So all the test cases seem to pass. Yes, they have passed. Thanks for watching. Please subscribe to my channel, like the video. Okay, let's quickly see the C++ code as well. There is some twist in C++ code. So here, if you see, right, the base condition is same. Everything is same here, right? Left, we are pressing the left child, then right child. Then we are checking here. We are checking for whether it is half node. Okay, if it is a left child and right, if it is a right child, right, and does not have a left child, then what we are doing here is the extra step is we are storing the right child, right, into this new root. We are freeing the half node. We are deleting as to avoid the memory leak, right? We are deleting the half node, and then we are returning the right child. Okay, as part of new root. Similarly here also, we are storing left child into the new root, then we are freeing that half node, right? And then we are returning. That's what is the difference here. Okay. So I hope you've got the solution. Okay. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.